In section 2.1, we will talk about radian measure. So first of all, what are radians? We know that a circle has 360 degrees. Radians are alternate units used to measure angles in trigonometry. So to relate degrees to radians, 360 degrees is equivalent to 2 pi radians. So if we divide both sides by 2, then pi radians is equivalent to 180 degrees. Okay, so pi radians is equivalent to 180 degrees. We can make some ratios out of this. If I divide both sides by pi radians, then I get 1 equals to 180 degrees divided by pi radians. So this ratio is equivalent to 1. And same thing goes the other way. If you have pi radians over 180 degrees, that is also equivalent to 1. Now, why use radians? Well, radians are a natural way to measure arc length, angular velocity, linear velocity when it comes to a circle, because notice that radians are in terms of pi, and we know that in a circle, our radius is 2 pi r, our area is pi r squared. So it helps us measure angular velocity, arc length, linear velocity, things that occur in circles. So sometimes radian measures are extremely helpful. And when you get to calculus, you're going to be using radians more and more. So we have to know these two ratios, that pi radians over 180 degrees equals to 1, and 180 degrees over pi radians also equals to 1. Now, to convert from degrees to radians, we're going to multiply any angle that's in degree form by pi radians over 180 degrees. And we can do this because it's the same thing as multiplying by 1, and we can multiply anything by 1. So let's take some examples here. Part A, we have 390 degrees, and our task is going to be to convert this into radians, because right now it's in degree form. All right, so gotta shuffle some papers here. Okay, so if I take 390 degrees and I want the degrees to cancel out, so because I want the degrees to cancel out, the 180 degrees is going to go on the denominator, and I want my answer to be in radians, so the pi radians will be on the numerator. Okay, multiplying by pi radians over 180 degrees. I have to reduce this, so when I reduce it, the zeros are going to cancel out. I have 18 and 39. 3 goes into both, so 3 goes into 18 6 times, and 3 goes into 39 13 times. So my answer is going to be 13 pi over 6 radians. And I don't have to write radians when something does not have a degree sign. That means it's going to be in radian form. Next is 120 degrees. So once again, I'm going to multiply this by pi over 180. This is pi radians over 180 degrees. So the degrees cancel out. Now the zeros are going to cancel. 6 goes into 12 twice, and 6 goes into 18 3 times. So in radian form, this will be 2 pi over 3 radians. Okay, next one we have 90 degrees. We're going to multiply by pi over 180. So 90 goes into itself once, it goes into 180 twice. So 90 degrees is equivalent to pi over 2 radians. And then lastly, we have 200 degrees. So we're going to multiply this by pi over 180. The zeros cancel. 2 goes into 20 10 times. 2 goes into 18 9 times. So this will be 10 pi over 9 radians. Okay, so to multiply, to convert from degrees to radians, you're going to multiply by pi radians over 180 degrees. Next up, we want to convert from radians to degrees. So to convert from radians to degrees, we go the exact opposite way. You want the radians to cancel, so the radians go on the denominator, and you want your answer to be in degrees, so the degrees go on the numerator. Okay, so we're going to multiply this angle in radians by 180 degrees over pi radians, so the pi's cross cancel. 6 goes into 80 30 times, and 30 times 5 will give you 150 degrees. Next one, we have negative 1.3 radians, so we have negative 1.3. We're going to multiply this by 180 degrees over pi radians. Now you can put this straight into your calculator. Put negative 1.3 times 180 divided by pi. And then if you do this, this will give you 74.485 degrees. Next one is 9 pi over 10 radians. So we're going to multiply this by 180 over pi. The pi's cross cancel. 10 goes into 180 18 times. And then if you have 18 times 9, this will give you 162 degrees. Lastly, we have negative 11 pi over 5. We're going to multiply this by 180 over pi. So the pi's cross cancel. And then you can just, in your calculator, take negative 11 over 5 and multiply that by 180. And then this will give you negative 396 degrees. Let's find the exact value of each of the following. So what I recommend doing is converting each of these into degrees before you graph it. So let's start with the first one. We have 11 pi over 4, that's in radian form, and we want to convert this into degrees, so we're going to multiply by 180 over pi. So the pi's are going to cross cancel. In your calculator, you can just multiply 180 times pi 11 over 4. And when you do so, you're going to get 495 degrees. Now we learned in chapter 1 that anytime your angle is not between 0 and 360, we can find a coterminal angle between 0 and 360. So if I take 495 and I subtract 360 from that, this will give me 135 degrees. So I want to basically find the sine of 135 degrees. So if I sketch 135, this is 0, we have 90, and 90 plus 45 is 135. So this is my angle. I need to find a reference angle for this. So my reference angle theta prime is going to be 45 degrees as well. And this is going to be my reference triangle. I need to find that corresponding point. So remember that for 45 degrees, the corresponding point is going to be rad 2 over 2 and rad 2 over 2. Notice that we're going left, so the x is negative, and we're going up, so the y is positive. Sine is always the y value when you have a ordered pair on the unit circle. So the sine is going to be radical 2 over 2. Okay, part B, let's find the cosine of 11 pi over 4. Now we know that 11 pi over 4 is 495, and 495 is equivalent to 135 degrees. So we want to now find the cosine of 135 degrees. And the cosine is going to be the x value, which is going to be negative radical 2 over 2. Tangent, again, 11 pi over 4 is going to be 495. If coterminal angle is 135, so we want the tangent of 135 degrees. Tangent is going to be the numerator of the y value, which is going to be radical 2, divided by the numerator of the x value, which is going to be negative radical 2. So our tangent is going to be negative 1. Okay, part D, we want to find the cosecant. Well, we know the sine is radical 2 over 2. So the cosecant is going to be the reciprocal of that, which is going to be 2 over radical 2. We have to rationalize this, so we're going to multiply both sides by radical 2 over 2. So this gives us 2 radical 2 over 2. The 2's cross out, and we're left with radical 2. Secant of 11 pi over 4 is the reciprocal of negative rad 2 over 2. So this gives you 2 over negative radical 2. Same thing, multiply both sides by radical 2, or numerator and denominator. And this gives us 2 radical 2 over negative 2, cross those out, and we have negative radical 2 as the secant. And then for the cotangent, we take the reciprocal of negative 1, which is just going to be negative 1. Okay, let's find the exact value of each of the following. First off, I need to know what is negative 7 pi over 3 in degree form. So I'm going to multiply this by 180 over pi. These are going to cross out. 3 goes into 180 60 times. 60 times negative 7 is negative 420 degrees. I need a coterminal angle between 0 and 360. So I'm going to add 360. This gives me negative 60 degrees. I'm going to add 300 degrees again. I could graph negative 60 if I wanted to, but I'm just going to add 360 again, and this will give me 300 degrees. But remember, negative 60, as long as I'm between 0 and 360 or 0 and negative 360, I can graph those. So I'm going to get 300 degrees, or you can just stop there and graph negative 60 degrees. It's the same angle. So if I graph 60 degrees, that's going to be 90, 180, 270. Now I need to get to 300, so 270 and 30 is going to be 300. So my reference angle, my theta prime, is going to be this angle here, which is going to be 60 degrees. The corresponding point, so for 60 degrees, my corresponding ordered pair is going to be 1/2 and radical 3 over 2. The x is positive and the y is negative, so this will be negative radical 3 over 2. That's my ordered pair on the unit circle. If I had graphed negative 60 degrees, the same thing would have happened. My reference angle would have, again, come out to be 60 degrees. So now sine is the y value, which is going to be negative radical 3 over 2. Cosine is the x value, which is going to be 1/2. And then I don't want tangent, I want cotangent. So first I want to find tangent. Tangent of negative 7 pi over 3 is going to be the y value of, the numerator of the y value, that's negative radical 3, divided by the numerator of the x value, which is 1. But I want the cotangent, so I'm going to flip that. So the cotangent of negative 7 pi over 3 is going to be negative 1 over radical 3. And then if I rationalize that, this gives me negative radical 3 over 3.